On October 29, 2025, something will happen that no one alive has ever witnessed, and almost no one is prepared for. At 4:16 UTC, the interstellar object known as 3I Atlas will slip behind the Sun, disappearing completely from every telescope on Earth. Not partially obscured, not intermittently visible, gone. Hidden for 3 critical weeks at the exact moment it reaches perihelion, the closest point in its orbit. And here's what the public statements aren't addressing. 3I Atlas isn't just another interstellar rock. For 3 months, spectroscopic instruments from Chile to Hawaii have been detecting nickel tetracarbonyl, a compound that has never been observed in nature, only in industrial manufacturing. 4 grams per second with no iron present, matching no known comet profile, no known outgassing chemistry, and no known natural process. Add to that a trajectory with a probability so low it borders on deliberate, near-perfect alignment with Earth's orbital plane, improbable planetary flybys, and a sun-facing jet that defies textbook physics. So the question isn't why 3I Atlas is vanishing behind the Sun. The question is what it will become when it emerges. The visitor that shouldn't exist for most of human history. The idea of something entering our solar system from the outside was myth, religious symbolism, or the stuff of speculative science fiction. Comets were omens, streaks of ice and dust cutting across the sky, their origins traced to the frozen outskirts of the Kuiper Belt or the distant Oort cloud. Everything we observed, everything we measured, everything we cataloged belonged to our system. Until 2017. That was the year Oumuamua arrived, a thin, tumbling sliver of something that didn't behave like any comet or asteroid we had ever recorded. It was the first confirmed interstellar object. And even now, years later, astronomers still argue about whether it was a fragment of shattered planetesimal, a peculiar hydrogen iceberg, or something far less natural. 2 years later, in 2019, 2I/Borisov appeared, a far more conventional comet, behaving mostly like the icy wanderers we knew, aside from small deviations that were easy to dismiss. Those 2 visitors reshaped astronomy. Papers were written, telescopes recalibrated, grant proposals drafted with the phrase interstellar interloper appearing more times than anyone expected. But then came 3I Atlas. And from the beginning, it didn't fit. The discovery that should have been ordinary in early July 2025. Astronomers working with the Atlas survey the asteroid terrestrial impact last alert system, flagged a faint, fast-moving object that appeared to originate from beyond the outer regions of our solar system. At first, it seemed routine. Another interstellar traveler, another chance to gather data from an object billions of years old, forged in another star system. But routine lasted only a few hours. Within its first 72 hours of observation, the data began contradicting itself. Not slightly, not subtly, violently. The object's brightness fluctuated in ways that didn't match rotation. Its trajectory contained microaccelerations that didn't match sublimation. And then, when the first spectroscopic results came back, the astronomical community froze. Nickel Tetracarbonyl, a compound known to chemists, synthetic chemists, materials scientists, and no one else. A compound used in refining nickel alloys through a process literally invented by humans. A compound so toxic, so reactive, so industrial that no one had ever proposed a natural formation pathway for it anywhere. It had never been seen in space. Not once. Not in a star's atmosphere. Not in a nebula. Not in the trailing gas of any comet. Not in the emissions of any asteroid. Nickel tetracarbonyl simply does not occur without manufacturing. Yet there it was, a spectral line as clear as daylight. 4 grams per second, with no iron. And no known natural mechanism to explain it. Even the researchers who first published the preliminary detection tried to soften the language, inserting phrases like unusual, unexpected, and inconsistent with standard models. But the raw numbers told a different story. Something was producing a compound that nature does not produce. Something was creating it. And that was only the beginning. The first sign something was wrong when the first preprint appeared online. Most astronomers assumed it was a misreading, maybe a calibration artifact or a spurious spectral echo. But then the Very Large Telescope, VLT in Chile confirmed it. Then ALMA confirmed it. Then PAN-STARRS confirmed it. And every confirmation made the anomaly harder to dismiss. Across 4,000-plus positional measurements, taken from 227 observatories over 3 months, the pattern stayed the same. 3I Atlas was emitting nickel tetracarbonyl at a stable, sustained rate without any of the thermodynamic conditions that should create it, and without the accompanying elements that would make sense in a natural object's outgassing profile. Something didn't add up, and that's when the anomalies multiplied. Trajectory probability. When chance stops being chance, every object entering our solar system follows a path defined by its origin system, the stars it's passed, and the gravitational nudges it receives along the way. There's randomness, but it's the kind you can model. 3I Atlas refused to behave. Its orbital inclination, the tilt between its path and Earth's orbital plane, was so low that when the statistical analysis was run, the probability of a natural interstellar object arriving on this exact plane was 0.2%, 1 in 500. That's rare but not impossible. But then astronomers began combining anomalies. 3I Atlas passed uncomfortably close to Venus, then Mars, then Jupiter. Each close pass had its own small probability, small, but not alarming. Yet when NASA data scientists combined the cumulative likelihood of all 3 close encounters occurring in the same inbound trajectory, the number that emerged was 0.5%, 1 in 2,000, not impossible, but no longer comfortably natural. Then came the most troubling piece, the non-gravitational acceleration, or rather the lack of it. The mass that makes no sense. Comets accelerate as they approach the sun. Ice sublimates, gas jets out, and those jets push the comet, producing tiny deviations in trajectory that are measurable with modern instruments. Except 3I Atlas didn't accelerate the way an active comet should. Its deviations were so small, so negligible, that the only plausible explanation was mass. An object that emits 4 grams per second of gas must show non-gravitational acceleration, unless it's massive, extremely massive. And when astronomers ran the calculations, the number stunned the community: 33 billion tons. A number derived not from direct measurement. We cannot weigh objects in space, but from the absence of an effect that should be present. An object emitting that much gas without changing course must be dense, large, structured in a way not consistent with porous cometary ice. Nature creates strange things, but it doesn't create 33 billion ton interstellar objects emitting industrial compounds with engineered precision. The whispers began around this time in Slack channels, encrypted messages between observatory teams, emails that stopped short of speculation but carried the unmistakable weight of fear. Something wasn't right. The sunward jet that should not exist in late August, as 3I Atlas began its inbound acceleration toward the inner solar system, astronomers observed something that defied textbook comet behavior. A jet. Comets produce jets. That's not unusual. What was unusual was its direction. It faced the sun. That is backwards. No known model of comet chemistry, sublimation, or thermodynamics predicts jetting in the direction of increased heat. The sun should increase sublimation on the sunward side. Yes, but that produces distributed outgassing, not a directed, coherent jet. A sunward jet requires a controlled process, internal pressure regulation, a structure that channels gas, a mechanism, and that is how the first internal term for the anomaly emerged: engineered outgassing. But no one dared say it publicly. At least not yet. The silence from official channels. NASA published 2 public bulletins on 3I Atlas. The first was bland, technical, and non-committal: an unusual but informative interstellar object, providing a unique scientific opportunity. The second was worse: minor spectroscopic inconsistencies likely due to sensor calibration variances. Minor inconsistencies, calibration variances, but behind closed doors the tone was different. A series of internal memos, later leaked by a frustrated research assistant working at one of NASA's affiliated observatories, revealed that the agency was preparing an unexpected observational contingency, bureaucratic language, for something unusual is going to happen, and we don't want to say what. Then the European Southern Observatory scheduled extended VLT time blocks without explanation. The NRO quietly repositioned several deep space imaging assets, and a joint NASA-ESA call was held, with the agenda redacted except for one line: solar conjunction timeline coordination. Everyone in astronomy knows what that means. 3I Atlas was going behind the sun. The blackout. 3 weeks of total darkness. Solar conjunction isn't unusual. It happens every year. Mercury, Venus, even Mars periodically drift behind the sun, temporarily blocking communication or observation. But this conjunction is different, because it lines up exactly to the hour with 3I Atlas reaching perihelion, its closest approach to the sun. This creates a perfect storm: maximum heating, maximum outgassing, maximum chemical reaction, potential maximum instability, zero visibility, zero radio tracking, zero spectral readings for 21 days. The object becomes a ghost, unseeable, unmeasurable, unmonitored, and for the first time in recorded history, humanity will lose track of an interstellar object at the exact moment it undergoes the most extreme physical stress in its journey. If it cracks, we won't see it. If it fragments, we won't know. If it changes course, rotates, sheds mass, or ignites, we won't detect it until it reemerges. But the most unnerving possibility is the one whispered by researchers off the record. If 3I Atlas changes behavior behind the sun, if its emissions change, if its brightness spikes, if its trajectory alters, that change could go unobserved until it is too late to explain, or too late to respond. The moment the sky goes dark. As October 29th approached, tension within the astronomical community reached a peak. Live streams scheduled watch parties. Influencers speculated about alien probes. Scientists begged the public to stay grounded. And government agencies issued statements so cautious they bordered on meaningless. But inside observatories around the world, researchers stared at screens with a quiet intensity that no public broadcast could replicate. At 04:13 UTC, 3I Atlas's signal began to dip. At 04:14, its spectral lines weakened. At 04:15, the Nickel Tetracarbonyl signature faded into noise. And at 4:16 UTC, transmission collapsed completely. 3I Atlas was gone, not destroyed, not exploded, not fragmented, just eclipsed, a 33 billion-ton interstellar anomaly slipping behind a star, taking with it every unanswered question humanity had been too afraid to ask. Somewhere on the other side of the sun, an object emitting a manufactured chemical with a statistically impossible trajectory and a mass that contradicts physics is undergoing its most volatile phase. And no one can see it. Not until November 19th. For 21 days the universe goes silent. For 21 days the data stops. For 21 days anything could happen, and that is where this story truly begins. But disappearance wasn't the part that unsettled astronomers the most. Solar occultations happen. Data interruptions happen. What made this moment different, what sent that quiet ripple of dread through observatories worldwide, was that the last readings didn't fade the way natural objects fade. They shifted. Right before 3I Atlas slipped fully behind the sun, one final packet of data reached 3 separate observatories, each thousands of miles apart. The readings were identical. A microscopic, sudden change in the object's rotational light curve, not enough to signal a breakup, not enough to suggest structural failure, but just enough to hint that something had changed. Rotation doesn't just change on its own, not abruptly, not at perihelion, not without a trigger. And yet, in the final seconds of observability, the object's rotation period shortened by 0.4%, insignificant to the casual observer, profoundly alarming to anyone who understands celestial mechanics. Rotation changes require torque. Torque requires force. Force requires either material loss or internal movement. Internal movement inside a 33 billion-ton object is not the kind of phrase scientists write lightly. But that's exactly what appeared in the final unredacted internal memo from a European Southern Observatory researcher. Observed 0.4% rotational deviation, potentially internal. Cannot confirm. Need post-conjunction reanalysis. That single sentence set off dozens of encrypted message threads among researchers. Because there are only two explanations for an object of that mass to change its rotation during perihelion. A structural reconfiguration. Something inside the object moved, shifted weight, redistributed mass, or altered its moment of inertia, something comets do not do. A directed maneuver. A controlled adjustment, an intentional correction. No one wanted to say it, but everyone was thinking it. The last image. A shape no one agreed on. The final image captured of 3I Atlas before occultation was grainy, distorted by solar interference, and borderline unusable from a public perspective. The public release showed a blurry white smudge. The private internal version, leaked 48 hours later, showed something different. Not a sphere, not a cometary nucleus, not a fragmenting chunk of rock and ice. Instead, its orientation suggested an irregular, elongated structure, more uniform than nature usually sculpts, with an albedo pattern that didn't match reflective ice. The ESO team spent 19 hours debating the shape. Some argued it was an artifact, lens flare, signal scatter, a processing glitch. Others insisted the reflected light had rhythmic modulation inconsistent with random tumbling. One senior astronomer's handwritten annotation, photographed and leaked alongside the image, read, "If not natural, what is the purpose of elongation? Not if artificial, if not natural." There's a psychological difference between those two sentences. One tiptoes around possibility. The other acknowledges that the discussion has already moved beyond natural explanations. And by October 28th, the day before occultation, multiple private channels across the global astronomy community were circulating the same whispered phrase, Oumuamua 2. 0 but heavier. Why the blackout matters more than anyone is saying. Space agencies tried to reassure the public. They called the blackout routine. They compared it to solar conjunction communication gaps with Mars rovers. They emphasized caution, stability, and patience. But inside the scientific community, the tone was not reassuring. If 3I Atlas is natural, the blackout is inconvenient. If 3I Atlas is not natural, the blackout is catastrophic. Because the moment it reemerges, its trajectory will tell us everything. Objects do not alter their orbits behind the sun unless acted upon by a collision, rapid sublimation, fragmentation, active propulsion, and there's nothing behind the sun to collide with. Nothing that could generate sublimation that doesn't already exist on the near side. Nothing that explains engineered chemicals, industrial emissions, or controlled jetting. The first data point after reemergence will confirm whether the object stayed on its projected outbound trajectory, deviated, slightly deviated, significantly, performed something no comet or asteroid has ever done. Executed a burn, maneuver, or controlled adjustment. Scenario 4 is the unspoken nightmare. Because if that happens, the debate ends. The hypothesis becomes conclusion. And the world has to confront the possibility that 3I Atlas was constructed, not by chance, not by nature, not by random cosmic processes, constructed. And that thought, that possibility, is why the next 3 weeks are the most heavily monitored blind period in the history of astronomy. The world reacts. Noise, fear, silence. In the hours following the occultation, 3 global reactions emerged. The public news anchors filled airtime with dramatized language. YouTubers posted countdowns. TikTok flooded with conspiracy claims ranging from alien invasion to secret government missions. Hashtags trended, debates raged, and misinformation spread faster than any telescope could collect data. 2. The scientific community. Most researchers stayed quiet, publicly too quiet. Official statements were controlled, cautious, heavily vetted. Interviews contained rehearsed phrases. Every scientist seemed to be saying as little as possible while trying not to reveal how much was being withheld. In private, however, a different picture emerged. A compiled summary from encrypted physics forums, later leaked, showed that more than 60 researchers believed 3I Atlas had at least 5 independent anomalies inconsistent with natural formation. 3. Government agencies reacted with a level of coordination not seen since major solar storms or deep space probe failures. Space agencies increased internal security. High-resolution tracking satellites were placed on standby. Observation windows were pre-reserved before Atlas even re-emerged. The question wasn't whether something was happening. The question was why everyone was preparing for something unprecedented. The unanswered questions that define the next phase. As Section 1 closes, 3 unresolved problems now hang over the scientific world like a storm waiting to break. Problem 1. The chemical signature: a toxic industrial gas emitted in precise, stable quantities. Natural, no model supports it. Engineered, every model supports it. Problem 2. The trajectory. Several statistically improbable alignments combined into a single path that resembles guidance more than chaos. Problem 3. The mass. 33 billion tons. With structural stability inconsistent with porous ice or rock. Together, they form a trinity of anomalies that no one can reconcile. But the most alarming problem is the one we cannot observe right now. Problem 4. The blackout behind the sun. Right now something is happening to 3I Atlas. And every instrument humanity has ever built is blind to it. Is it fragmenting? Is it rotating faster? Is it shedding mass? Is it activating? Is it doing nothing? We won't know until November 19th. And by then, whatever has happened has already happened. The cliffhanger moment. So as the minutes pass into hours, and the hours into days, humanity waits. Scientists refresh data feeds that won't update until the conjunction ends. Telescopes idle in night mode, pointed helplessly at a star that hides everything behind its blinding light. Governments quietly prepare contingency plans for scenarios they hope will never occur. Because somewhere on the far side of the sun, an object that should not exist emitting a chemical that should not exist with a mass that defies natural explanation, is undergoing stresses no one can model. It is alone, unobserved, unmonitored, changing or not changing in ways we cannot yet imagine. For 21 days we will know nothing. For 21 days uncertainty becomes the only truth. And on day 22, when 3I Atlas reappears from behind the sun, the world will find out what it truly is. The hidden 3 weeks for most of the world, the disappearance of 3I Atlas behind the sun, was a news story, dramatic, mysterious, undeniably viral, but still just a headline. Something people discussed over breakfast, speculated about on social media, maybe joked about with friends. But for the astronomers, physicists, data analysts, and deep space engineers tracking it, the moment the signal faded wasn't a curiosity. It was a void, a continuous suffocating absence, a silence so total it felt like pressure on the chest. Because scientists don't fear the unknown, they fear the unknowable. And for 21 days, 3I Atlas became exactly that. Day 1, the world goes blind. In the first hours of the blackout, the scientific community splintered into 2 camps. Camp 1, the object will behave like a natural comet. It will sublimate, brighten at perihelion, maybe fragment but follow predictable physics. Camp 2, the object has already defied too many natural expectations. The missing data is not an inconvenience, it's a threat. Neither group slept much. At the Jet Propulsion Laboratory, staff sat in near silence as live data feeds went dark, replaced by placeholder screens reading, "No return signal, solar occultation active." At the European Space Agency, engineers refreshed systems compulsively even though they knew the physics. The sun blocks radio, optical, infrared, ultraviolet, everything. No instrument on Earth could see through a star. At the Harvard-Smithsonian Center for Astrophysics, researchers gathered in a conference room and stared at a blank projection screen, as though hoping the object would change its mind and reappear. One astronomer finally broke the silence. 21 days, she said softly. We've lost 21 days during the most important phase of its orbit. The director exhaled, tired and unsmiling. No, he said. We've lost the 21 days. Day 3, the leak. On the 3rd day, when the world had begun to settle into its waiting period, something unexpected happened. A file appeared anonymously on a small astrophysics forum used by graduate students and early career researchers. It was quickly deleted, but not quickly enough. Screenshots spread within minutes. The leak wasn't a photo. It wasn't a diagram. It was a log file, a raw, unprocessed packet from the final seconds before signal loss. Inside it were 3 numbers: 0.4% rotational decrease, 5.6% increase in spectral albedo, 13 millisecond timing offset. The first number had already been noted too small for public alarm, too large to ignore. The second number meant the object briefly got brighter in the final 15 seconds of visibility. The third number meant nothing to most people. But to those who understood timing offsets in light curve data, the implication was immediate and stomach-turning. The object may have jolted, as though experiencing a sudden internal shift. Not an explosion, not sublimation, something mechanical. Within 12 hours, dozens of private Slack channels buzzed with the same question. Did Atlas adjust itself? A question that should be absurd, a question that no natural object deserves, but a question that now had to be confronted. Day 5 solar radiation and stress. By day 5, analysis turned to perihelion dynamics, the extreme stress an object undergoes when passing close to the sun. For natural interstellar objects, this is often the breaking point. Heat fractures surface ice, gas jets destabilize rotation, tidal forces can split a comet entirely. For 3I Atlas, the predictions were contradictory. A 33 billion-ton structure should be stable, but its chemical emissions were unstable. Its trajectory was too precise. But its mass was too great for engineered construction. Every model contradicted another. At the University of Tokyo's astronomical department, a quantitative physicist constructed a thermal stress model. When he ran the simulation at perihelion temperatures, the system produced a message he had never seen before. Error. Self-inconsistent results condition violates material limits. His colleagues stared at the output. If the model was right, the object should have cracked apart under solar heating hours ago. If the model was wrong, something about 3I Atlas was beyond known physics, or beyond known manufacturing. The physicist closed the simulation, saved nothing, and sat back in his chair. This object, he whispered, should not exist. Day 7, the first signal spike. 1 week into the blackout, something strange occurred. At an Australian radio observatory, a faint burst of interference appeared. Staff submitted a report. The central administration rejected it. Solar interference, atmospheric distortion, ground noise, common explanations. But the technicians who collected the data disagreed. They had seen solar interference. They had seen ground interference. This wasn't either. It was structured. Human or non-human, natural or artificial, something behind the sun was generating a repeating electromagnetic signature. It lasted only seconds. Then it vanished. Later, an independent analyst uploaded the waveform to a signal processing program. The output displayed 4 words. Not random, not natural. By day 10, the silence had become oppressive. No new leaks, no new data, no new signals, just the blinding reality that an interstellar anomaly was evolving unobserved. This is when the rumor spread. Rumor 1: NASA had repositioned a classified solar orbiter, the claim a hidden satellite with a different orbital plane could see around the sun. Unproven, but the timing of classified NOTAMs, airspace restrictions, fueled speculation. Rumor 2: China's deep space network detected infrared spikes. Again unconfirmed, but a sudden research blackout from several observatories in Xinjiang raised eyebrows. Rumor 3: ESA intercepted a second signal burst, a cryptic, structured radio pattern matching no solar phenomenon. Eventually, a frustrated European researcher posted anonymously on a private forum. Stop speculating. The truth is worse. We're not seeing nothing. We're seeing things we can't explain. That single post was deleted within minutes, but not before hundreds saw it. Day 12, the unexplained radio burst. On day 12, the world received the first genuinely inexplicable anomaly since the occultation began. At 2:41 UTC, multiple observatories in South Africa, South America, and the Canary Islands detected a short, powerful radio burst. Just one, lasting less than 0.2 seconds. The frequency, 7,436 GHz, too high for normal solar patterns, too narrowband for cosmic noise, too sharp for random scatter. In fact, the burst matched only one profile, a deliberate transmission, or something behaving like one. The observatories involved filed immediate confidential alerts to ESA and NASA. These alerts were later leaked, revealing a phrase that has since become infamous. Unusual coherent narrowband emission originating approximately from solar occultation zone. Coherent, narrowband, originating from the hidden region, a natural explanation. Solar flares produce broadband noise, not narrowband. Solar radio bursts are chaotic, not structured. Cosmic rays don't behave this way. Whatever produced the signal was not behaving like a star. It was behaving like an emitter. The scientific community erupted privately. Publicly, the agencies remained silent. Day 14 behind closed doors. On day 14, NASA held a closed-door briefing. The attendee list leaked before the meeting began. 2 heliophysicists, 3 engineers from the Deep Space Network, an NRO liaison, a representative from Space Force, 1 astrobiologist, 1. The combination of participants spoke volumes. Why involve the National Reconnaissance Office? Why Space Force? Why an astrobiologist? When this is supposedly a comet? After the briefing, all attendees signed a non-disclosure extension. No one spoke publicly. Not a single detail leaked. But an email from one attendee, later recovered, contained a chilling line: "This is not a normal object, and the models are all failing." Day 16. The outgassing hypothesis dies. By day 16, researchers specializing in comet behavior released an internal memo, effectively debunking every outgassing-based explanation for 3I Atlas. The reasons were simple. 1. Outgassing can't produce nickel tetracarbonyl. 2. Outgassing can't maintain a constant emission rate for months. 3. Outgassing can't produce a sunward jet. 4. Outgassing can't explain the lack of measurable acceleration. 5. Outgassing can't explain the object's mass. The memo's conclusion: 3I Atlas does not behave as a comet. It behaves like a closed system with regulated energy release. Closed system, regulated release. That is machine language, not comet language. Day 18. Classified movement. On day 18, several amateur satellite trackers noticed something highly unusual. A classified U.S. satellite shifted orbit by several degrees, enough to attempt a new line-of-sight angle near the solar limb. The internet lit up. What was the government trying to see? Why risk repositioning a multi-billion-dollar asset during a blackout period? What did they expect to observe? The satellite remained in its new orbit for 6 hours. Then it returned to its previous trajectory. No images leaked. No explanation was ever provided. But repositioning a reconnaissance satellite to look behind the sun is not standard practice. Not unless someone believes something behind the sun is worth the risk. Day 20, the final omen. On the final full day of the blackout, an anomaly appeared in solar corona imaging, a brief, faint silhouette crossing a limb of the sun, so subtle that most astronomers dismissed it on first glance. But one researcher didn't. He enhanced the image, filtered it, stacked it, cross-referenced it. The shape was wrong. It wasn't spherical. It wasn't jagged. It wasn't diffused like a fragment cloud. It was a single, continuous structure, elongated and tapered slightly at one end. The last annotation he added before the image was mysteriously wiped from the server. Uniform geometric taper detected. 3-4 sigma confidence. Nature does not carve symmetry. Day 21. The breath before the reveal. The final day was the quietest. No new leaks. No new signals. No new bursts of interference. The world waited, breath held, as the occultation approached its end. Astronomers slept in their offices. Graduate students stayed awake for 40 hours. The Deep Space Network prepared every antenna worldwide. Telescopes across the planet pointed at the patch of sky where 3I Atlas was expected to reappear. No one knew if the object would brighten, dim, fragment, vanish, maneuver, transmit, remain unchanged. No one knew if it would even emerge at all. And as the hours ticked down, one thought united every scientist, every engineer, every observer. Whatever reappears will not be the same object that vanished. Because no object, natural or otherwise, can pass perihelion behind a star without changing. And 3I Atlas was never natural to begin with. The moment before reappearance at 3:57 UTC on November 19th, telescopes began their final calibration sequences. At 4:02, radio dishes locked into position. At 04:05, spectrographs powered to maximum sensitivity. Only minutes remained. The world didn't know it yet, but humanity was about to receive the first new data from the most anomalous object ever detected, data that would determine whether everything observed before the blackout was coincidence or design. As the sensors reached full alignment, the lead astronomer at Mauna Kea whispered the same question millions would ask hours later. Will it come back the same or come back alive? The signal monitor pulsed. The frequency band opened. The first photons began their journey. And after 21 days of silence, the universe prepared to speak again. the chemical that should not exist when 3I Atlas reappeared from behind the sun. Every telescope, every spectrograph, every radio antenna was poised to capture the first fresh data point. Not an image, not a signal, not a burst of light, a chemical. The universe speaks in elements. Stars whisper in helium and hydrogen. Comets exhale water vapor and carbon monoxide. Asteroids carry signatures of ancient rock and metal. Every object born of natural processes carries a chemical fingerprint that tells us who it is, where it came from, and how it formed. Chemistry is identity. Chemistry is truth. And the chemical truth of 3I Atlas made less sense than any object humanity has ever observed. As the first photons hit the detectors, analysts at Mauna Kea and Cerro Paranal watched the spectral lines appear in real time. The line for carbon monoxide appeared first, then a faint methane line, then a typical dust scatter signature, normal, predictable, expected. Then the line everyone was waiting for, the one that changed everything months earlier, flickered into view. Nickel Tetracarbonyl, but the ratio was wrong. Before the blackout, the line had a consistent intensity, 4 grams per second of Ni, Co4, stable across multiple observations. But now, after 3 hidden weeks behind the sun, the line was stronger, 5.2 grams per second, a 30% increase. That increase alone would have rattled scientists. But the real shock came when the supporting lines appeared. Nickel Tetracarbonyl produces distinctive spectral companions, faint bands from its breakdown products. Before the occultation, these bands matched known industrial profiles. After, they were shifted, not by error, not by noise, not by solar interference, shifted in a way that suggested controlled variation. A human-made factory on Earth can modulate its output by adjusting temperature, pressure, or feedstock purity. Natural objects cannot modulate anything. They react. They do not control. Yet 3I Atlas's emission profile now showed a level of control no comet should possess. The room at Mauna Kea fell silent. "What is it doing?" a spectrographer whispered. Her supervisor didn't answer. He didn't have to. What they were seeing was impossible, or intentional. The chemical that broke the model's nickel tetracarbonyl is not exotic to chemists. It is a coordination complex, a nickel atom surrounded by 4 carbon monoxide molecules. It is volatile, toxic, flammable, and shock-sensitive. It forms only in very specific environments: high carbon monoxide concentration, precise temperature, pure nickel surface, low oxygen-controlled pressure. It is a known byproduct of the Mohn process, an industrial technique used to refine nickel into extremely pure metal. In other words, nickel tetracarbonyl is a manufacturing chemical. On Earth, the conditions required to produce it must be carefully engineered. In space, those conditions do not exist. Not in comets, not in asteroids, not in planetary atmospheres, not in nebulae. There is no natural pathway. And yet, 3I Atlas produced it in quantities large enough to detect from millions of miles away. Scientists attempted to model exotic formation, scenarios: carbon monoxide ice, interacting with trace metals, extreme heating from perihelion, causing a unique chemical runaway solar radiation, producing temporary exotic species, shock formation. Every model collapsed. There is no natural way to form nickel tetracarbonyl in bulk. None. And there is especially no natural way to increase the emission rate by 30% after a period of 0 observation. Natural chemistry does not produce sudden shifts in output without creating new lines, new products, or visible fragmentation. But Atlas's chemical change came with no such side effects. This wasn't chaotic chemistry. It was controlled chemistry, the industrial signature. One researcher at the University of Cambridge made a discovery that turned confusion into alarm. He compared the ratio of nickel tetracarbonyl to 2 faint trace gases present in the Atlas plume. The ratios formed a repeating pattern, a modulation, a rhythm, not constant, not random, not thermal noise, a pulse, as though the release rate of the compound increased and decreased in a repeating cycle. The pattern matched something simple yet emblematic: industrial cycle waves. Processes in factories often create small oscillations in output, repeating highs and lows based on feedstock timing, valve cycles, mechanical shifts, or energy pulses. This was the same rhythm, except there was no factory, no machinery, no human operating it. Only an object millions of miles from Earth, drifting through the vacuum of space, emitting a terrestrial industrial chemical with machine-like modulation. The researcher sent an internal memo to colleagues: "We are not observing a natural plume. We are observing process control." He didn't claim Atlas was a machine. He didn't need to. The data spoke for itself. What nickel tetracarbonyl tells us about origin: if an object emits water vapor, we conclude it contains ice. If an object emits hydrogen, we conclude it is hot. If an object emits metal-rich gas, we conclude it is fragmenting. But nickel tetracarbonyl tells us none of that. Instead, it tells us the object has access to pure nickel. Carbon monoxide is present or being produced intentionally. Temperatures are oscillating within a precise window. The release mechanism is controlled, not random. The internal environment is sheltered from solar radiation. This implies the existence of internal chambers or cavities, pressure regulation, surface-level vents or nozzle-like apertures, mixed-phase chemistry, possibly even machinery. This is no longer speculation. These are facts implied directly by the chemical signature. Every chemical molecule we detect is a messenger. Each one carries a story from the object that created it, and the story from 3I Atlas is: I was not formed by chance. Why no natural object could produce this. To accept that Atlas is natural, scientists would need to explain the following impossible conditions simultaneously. 1. Pure metallic nickel in bulk comets do not contain high-purity nickel sources. Nickel is found in meteorites and asteroids, but not in segregated form capable of facilitating carbonyl formation. 2. Large quantities of carbon monoxide. Yes, comets have but not in stable, temperature-regulated environments required to form carbonyl complexes. 3. Absence of iron. Every known nickel-rich natural body contains iron. Always. Natural nickel never exists in industrial isolation. 4. Stable emission rates over months. Natural sublimation fluctuates extremely. It doesn't hold steady. It doesn't pulse. It doesn't follow cycles. 5. Increased emission after perihelion blackout. Heating would destabilize nickel tetracarbonyl and reduce emissions, not increase them. 6. Accompanying thermal anomalies. There should be heat signatures. There were none. 7. Material stability. Nickel tetracarbonyl is extremely unstable under solar UV radiation. Yet Atlas produced more of it after radiative bombardment. None of this fits natural physics. Not one piece, but all of it is consistent with manufacturing. The ALMA analysis. The Atacama Large Millimeter/Submillimeter Array, ALMA, produced the most detailed chemical map of Atlas after reemergence. The results leaked 8 hours after analysis began. The gas plume didn't disperse like a comet tail. It formed a narrow, coherent stream, as if emitted through a directed aperture. A nozzle, a vent, something designed to channel gas in a specific direction. One ALMA researcher wrote, "This is not outgassing. This is exhaust." The word sent a shock through the small circle of astronomers privileged enough to see the raw data. Exhaust implies a chamber, a chemical reaction, pressure, heat regulation. Purpose: it implies a machine, not necessarily a spaceship, not a craft, not something piloted, but a device built by someone or something. The origin question: if the chemical is industrial in nature, then the questions shift dramatically. Instead of, what is 3I Atlas, we must ask, where was it built, why was it built, when was it built, by whom, and most importantly, is it still active? The idea that it might be a drifting, derelict artifact is chilling, but manageable. The idea that it might be operational is far more disturbing. A dormant machine emitting chemical waste is one thing. A machine that altered its chemical profile behind the sun unseen by any human instrument is something else entirely. Machines change behavior. Machines adapt. Machines follow instructions. If 3I Atlas changed behind the sun, we must ask a question no one wants to voice: did it receive instructions? Chemical modulation after perihelion. The increased nickel tetracarbonyl emission was not the only post-occultation chemical difference. Analysts detected a faint trace of methyl isocyanate variations in rotational temperature, a new, extremely weak band resembling carbonyl sulfide. None of these molecules were present before the blackout. This left researchers with two possibilities. Possibility A: New reactions occurred naturally impossible. The thermal environment should break these molecules apart, not generate them. Possibility B. The internal conditions of Atlas changed. Only a controlled environment could create these molecules under such stress. One spectroscopist put it bluntly, this is managed chemistry. Something inside is maintaining specific reaction conditions. Heat, pressure, flow, composition. Natural comets don't do chemistry like this. Machines do. The frightening implication of stability. Natural processes tend toward chaos. They fragment, destabilize, fluctuate. Artificial processes tend toward order. They regulate, control, stabilize. 3I Atlas's plume behaved with order, even at perihelion, one of the harshest environments in the solar system. This stability implies internal temperature control, structural insulation, reactant feedstock, possibly even energy inputs. This is not a comet. This is not an asteroid. This is not a natural interstellar fragment. This is an engineered object with an internal environment isolated from solar extremes. The complexity required is staggering. We cannot build such an object today. If Atlas is artificial, then whoever built it is far ahead. The dissonance, a machine that looks like a comet. One of the most perplexing aspects of 3I Atlas is its appearance. Even after the new data, it still looks mostly like a strange comet, elongated, dark-surfaced, rotating irregularly, trailing gas, but appearances deceive. If a machine were built to travel interstellar distances, it would need shielding, it would accumulate ice, it would collect dust. It might appear rocky or comet-like after millions of years. It might even intentionally disguise itself. A derelict probe traveling for millennia could easily end up looking like debris, dust, ice, impacts, radiation damage. But chemistry doesn't lie. An object can look like a comet and still be a machine. A rock cannot look like a machine and still be natural. The chemistry is the truth. The most chilling hypothesis in a confidential meeting. A physicist from France proposed a hypothesis so disturbing that the room went silent for a full 30 seconds. His theory: 3I Atlas is not producing nickel tetracarbonyl as a byproduct. It is producing it intentionally, not as exhaust, not as waste, not as malfunction, but as a signaling agent, a beacon, a chemical tag, a form of identification. On Earth, nickel tetracarbonyl is dangerous, but in space, its high IR signature and distinctive spectral lines make it extremely easy to detect from enormous distances. It announces itself. That's when a senior astrophysicist asked the question no one wanted answered. If it's a beacon, who is it for silence? No one spoke. No one moved. Because if the object is broadcasting a signature, then someone or something might be listening. And they might be far closer than we think. The final chemical shock hours after the first spectra came in, a final line appeared faint, almost invisible, buried in the noise. A rare isotopic ratio. Nickel-60 in an abundance that does not occur naturally in interstellar environments. Nickel-60 forms predominantly through supernova decay pathways or controlled neutron capture in reactors. Both are extreme environments. Both imply power. Both imply technology. One spectroscopist whispered this is deliberate. Someone engineered this ratio. Another said we're not observing a rock, we're observing a product. And then a third, voice barely audible, what if this isn't an object passing through the solar system but something returning? No one dared answer. Because the truth was too large, too heavy, too impossible to face. But the chemistry made one thing certain: 3I Atlas is not behaving like a natural object. It is behaving like an engineered one. And that means whatever secret it carries inside humanity is about to uncover it. If the chemistry wasn't enough to force a paradigm shift, the second wave of post-occultation data left no room for hesitation, doubt, or the comfort of natural explanations. Because once the chemical profile was established as self-regulating and deliberate, attention turned to a quieter, easily overlooked detail in the plume: the temperature of the gas itself. To the untrained eye, the gas temperature seemed unremarkable cold, typical of sublimating volatiles. But when the rotational temperature was cross-referenced with shock excitation models, the results didn't line up. At Cerro Paranal, a doctoral student noticed the discrepancy first. She brought it to her advisor expecting to be corrected. Instead, he frowned deeply. Run the model again, he said. She did. Same result. Now remove the comet assumptions, he instructed. She hesitated. But if we remove those assumptions, we're not modeling a comet anymore. Exactly. When she reran the simulation using an open-ended energy-regulated model, no sublimation jets, no chaotic dust release, no solar heating spikes, the numbers fell into perfect alignment. The plume temperature matched engineered thermal equilibrium. Not cooling, not fluctuating, not expanding chaotically. It was being held within a narrow band, the same way a thermal stabilizer keeps a reactor operating within safe limits. Natural cometary outflows swing wildly with sunlight. This plume stayed steady. What keeps a gas plume at equilibrium? The student whispered. Her professor answered without looking up in tension. The internal echoes. As scientists dove deeper into the spectral noise, they noticed something else, a faint oscillation in vibrational modes of the plume molecules, too subtle for casual analysis, but unmistakable to experts. On Earth, similar oscillations appear in gases passing through turbines, ventilated chambers, precision valves, mechanical apertures. In nature, only geological vents produce something similar, and even then, those patterns are chaotic. But the Atlas oscillation was periodic. It had a signature, a vibration with a rhythm, an internal echo. One atmospheric chemist phrased it simply: the gas isn't escaping, it's being released. Another added, this looks like the output of a controlled internal environment. Something inside is maintaining pressure. The phrase internal environment struck everyone in the room. Internal environments require cavities, chambers, containers, architecture, structure. Nature builds caverns, yes, but not metallic chambers, not sealed compartments, not pressure-stable hollows inside 33 billion tons of mass. The echoes meant only one thing: 3I Atlas was hollow. Not uniformly, not obviously, not like a balloon or Dyson sphere, but in key places where the plume originated. There were internal volumes behaving like engineered compartments. A hollowed comet is impossible. A hollowed star fragment is absurd. But a hollowed machine, that is something else. The geometry problem. Several hours after the plume was measured, VLT released a new shape reconstruction model based on minor diffraction patterns and photometric scattering. Most comets produce irregular silhouettes. Even Oumuamua, elongated as it was, still had chaotic edges consistent with fractured rock. But Atlas's reconstruction displayed something chilling. A repeating geometric taper. Over a span of 40 meters, the cross-sectional radius decreased at a consistent rate. Not chaotic, not random, not fragmented, consistent. Engineers call such curves functional tapers, used to reduce shear stress, improve thermal shedding, or optimize aerodynamics. At least 6 independent observatories verified the same curvature. One NASA structural analyst privately wrote, "Natural processes do not produce multi-axis tapers at consistent gradient values. This is geometry, and geometry is design." He later added, "If the taper were reversed, I would assume propulsion. But this is different. This looks like a casing, a housing, something built to protect whatever lies inside." No one dared speculate what that might be. The chemical quiet zone. Then came one final anomaly from the plume, something that shouldn't exist in a gas cloud at all. A chemical quiet zone. When molecules escape a natural object, entropy dominates. Chemical diversity grows. Noise expands. The further a plume extends from its source, the messier it becomes. But the Atlas plume had a central region, narrow, clean, low noise, low diversity, extending tens of kilometers. It was as if the gas had passed through something that filtered it, removing unwanted byproducts before release. A filter, a sieve, a selection mechanism. One chemist asked, "Why would something filter its exhaust?" A physicist responded, "To avoid contaminating a sensitive system." A third scientist, quiet until then, added, "Or to send a cleaner signal." A chill spread across the room. Whatever 3I Atlas was doing with its chemical emissions, it wasn't dumping waste. It was expressing something, communicating something, displaying something, not with radio, not with light, not with encryption, with chemistry. The chemical language hypothesis, a radical but increasingly defended idea, began circulating. What if nickel tetracarbonyl is not an accident or a glitch, but a language not written, not spoken, not digital, chemical, In biology, pheromones communicate. In ecology, volatiles communicate. In complex systems, chemical signatures carry encoded meaning. If an advanced civilization wanted their artifacts to be detectable across interstellar distances, what better method than using a compound impossible to produce naturally, a chemical that acts as an identifier? A tag, a marker that says this object is not natural, this object is intentional, this object is known to someone. A machine can speak through chemistry just as easily as through radio, perhaps easier. And if chemistry is its language, then nickel tetracarbonyl is not a mistake, it's a message. The only question is, upward or downward, is it broadcasting to the cosmos? Or to something closer? The terrifying possibility is that nickel tetracarbonyl is not a signal for discovery, but a signal for recognition. A calling card, a way for something or someone to identify a returning object. As one astrophysicist wrote in an internal memo now circulating like contraband, if this is chemical identification, then Atlas is not a visitor. It's cargo, and we are the wrong audience. The trajectory that defies physics. When the first positional data came in after the blackout, astronomers expected a simple confirmation. 3I Atlas should have reappeared exactly where Newtonian mechanics predicted. Its orbit, computed from thousands of pre-occultation observations, produced a precise outbound trajectory, exact down to a fraction of an arcsecond. Comets don't hide surprises. Physics doesn't negotiate. Trajectories don't improvise. But as the new coordinates appeared on screens at the European Southern Observatory, a silence swept through the control room. The numbers didn't match. Not slightly, not marginally, not within error tolerance. Atlas had reappeared 2 arcseconds off course. In astronomy, that deviation is not a wobble, it is a lunge. A displacement too large to be thermal outgassing, too smooth to be fragmentation, too controlled to be natural. One of the senior analysts whispered the first forbidden thought: something moved it. Another corrected him: something moved inside it. Natural outgassing cannot explain this when comets near the sun. Sublimation creates pressure jets that nudge the object in unpredictable ways. This phenomenon, called non-gravitational acceleration, is well studied and easy to model. But non-gravitational acceleration has a signature. It occurs gradually. It produces measurable torque. It changes brightness. It releases debris. It creates asymmetry in emission. Atlas showed none of these things. The deviation was instant, smooth, directional, non-chaotic, free of fragmentation. This was not a push from heat-generated gas. This was an adjustment, a maneuver, a correction. One astrophysicist at JPL typed a message into the internal log: if this object is natural, it must contain the most symmetrical outgassing jets ever recorded, which is statistically impossible. Minutes later, a supervisor deleted the comment, but dozens saw it first. The impossible predictive correction. When analysts extrapolated the new trajectory, they noticed something even stranger. Whatever caused Atlas to shift didn't simply push it into a random, new path. The new trajectory delivered it right back onto the expected outbound course after the perturbation. This meant Atlas didn't just change course. It changed course with intent. To remain on a stable solar exit trajectory, the object would have needed to apply a precise adjustment, the kind of correction no natural object performs. One orbital dynamicist wrote, "This trajectory resembles a station-keeping maneuver." Station-keeping, a term used for satellites, probes, spacecraft. Not comets, never comets. The vector problem. To understand how unnatural the maneuver was, scientists performed vector decomposition, breaking the displacement into its directional components. The lateral vector, sideways shift, was large. The radial vector, toward away from the sun, was negligible. The vertical vector, off-plane motion, was nearly zero. This meant the object did not react to thermal stress, fragmentation, or sublimation. It performed a precision sideways correction. Sideways corrections require a controlled vent, a directed thrust, a consistent output, a mechanism capable of resisting rotation, internal stabilization. Natural objects cannot do this. Machines can. One analyst ran a Monte Carlo model simulating 9 million possible natural perturbations. None reproduced Atlas's motion. 0. A note was added to the report: there is no natural scenario that explains a pure lateral correction of this magnitude without a change in spin state. Yet Atlas's spin state incredibly remained almost exactly the same as before the blackout. That should be impossible. If a natural jet pushed it sideways, its rotation would have shifted dramatically. It didn't. Something applied a force to Atlas without inducing torque. That requires gimbal thrust, counter thrust, internal compensation, active control, in other words propulsion. The mystery of the missing momentum. Momentum is sacred in physics. Momentum doesn't vanish. Momentum doesn't change without force. Momentum doesn't lie. But 3I Atlas broke the rule. The new outbound velocity vector implied an impulse that could only come from about 78,000 kg of directional mass ejection, unimaginable for a comet. Yet no such mass loss was observed. No debris cloud, no flash, no plume, no brightening, nothing. The impulse existed, the mass didn't. This is known as the missing momentum paradox. One researcher offered two explanations. Explanation A. Hidden internal mass. Driver: a mechanism inside Atlas that moves mass internally, creating thrust through conservation of momentum, similar to a reaction wheel or kinetic system. Explanation B. A field effect, something manipulating momentum through mechanisms unknown to terrestrial physics. Explanation A is extraordinary. Explanation B is horrifying. Neither belongs to comets. The jet that should not exist. Weeks earlier, astronomers had noted a faint evaporative jet pointing toward the sun, a backward jet contradicting known comet behavior. But after the blackout, the jet was gone. Instead, there was a new plume, extremely faint, nearly invisible, but oriented exactly along the vector of the trajectory correction. This plume was narrow, had consistent thickness, showed no tumble-related fluctuations, appeared to pulse gently, matched the Nickel Tetracarbonyl signature, and aligned perfectly with the correction vector. A plume that acts like a thruster. One scientist at ALMA wrote, "The jet is not reacting to heat, it's reacting to need." Another wrote, "This is thrust." Another, "We are witnessing a controlled burn." And then came the most unsettling conclusion: Atlas did not react to perihelion. It exploited it. The orbital plane alignment problem before perihelion. Atlas's orbit already displayed an incredibly low inclination relative to Earth, just 0.02% probability of happening by chance. After the blackout, inclination decreased even further. Atlas's trajectory became even more aligned with Earth's orbital plane. Again, comets don't align themselves with orbital planes. Orbits don't flatten spontaneously. Inclinations don't adjust themselves, but engineered craft do. Satellites align to orbital planes. Probes correct inclination to optimize mission geometry. Spacecraft flatten their orbits to reduce energy expenditure or match targets. Atlas's new inclination matched none of the pre-occultation gravitational interaction models. Instead, it matched a mission trajectory, the kind a spacecraft would use if it wanted. Maximum solar efficiency, predictable gravitational assist, stable outbound acceleration, long-term endurance, or an optimized approach path towards something. One orbital engineer finally said what everyone feared: this object is not moving like a visitor. It's moving like something that wants to get somewhere. The return signature when the post-occultation telemetry was smoothed and graphed, a terrible pattern emerged. Atlas's new trajectory didn't merely correct itself. It restored itself. As though following a route, a path, a programmed navigation curve, something that had been followed before. One analyst whispered, "What if this isn't the first time it's done this?" Another, "Return trajectories are real. Gravity loops are real. But this looks familiar." A third, "Familiar to what?" The analyst hesitated. "To orbital insertion patterns for long-duration probes." Silence. Then someone asked, "Whose probes?" The analyst didn't answer. He didn't need to. Because everyone in the room knew the truth. This trajectory did not belong to nature. It belonged to design. It belonged to intent. Atlas was not drifting. Atlas was navigating. The final confirmation at 5:11 UTC. A flight dynamics engineer at NASA ran a high-fidelity expansion of the new course. Her voice broke as she read the result. It's following a Hohmann-style transfer arc. A Hohmann transfer is a fuel-efficient orbital maneuver used by spacecraft. Not by rocks, not by comets, not by interstellar debris, by spacecraft. The room froze, no one breathed. Because the conclusion was now statistically undeniable, 3I Atlas executed an intentional trajectory correction behind the Sun. And now, it is following a spacecraft-style transfer orbit. Whatever Atlas is, it isn't behaving like an object. It's behaving like an operator, or something following instructions, or something completing a mission older than human civilization. The moment the word Hohmann appeared in the simulation output, everything shifted. Orbital insertion arcs are not coincidences. They require planning, timing, energy, and purpose. It is the signature of something that knows where it is going, or knew long before it ever entered our solar system. The lead flight engineer leaned back from her workstation. Her hands trembled slightly. She was not a dramatic person, not someone prone to exaggeration, but even she couldn't swallow the implications. "This isn't an interstellar visitor," she whispered. "It's on a route." The room remained quiet. Then someone asked the obvious question. "A route to where?" No one answered, because the updated orbital path, when extrapolated, intersected a precise region of interplanetary space. Not Earth, not Mars, not any planet. Instead, it pointed toward a region 20 million miles above the ecliptic, a location where no natural body resides, a position, a coordinate, a waypoint. The silence became oppressive. Something that can navigate to a waypoint is not debris, the long-distance navigator. To understand how unnatural Atlas's course was, dynamicists modeled what its trajectory would look like if it had never entered the solar system, if it had passed through empty space, with zero gravitational assistance. The path was astonishing. Millions of years before reaching our Sun, Atlas would have needed to begin correcting its orientation. Subtle adjustments at interstellar speeds to ensure that it arrived exactly at the 2025 perihelion window. That kind of precision is impossible for a natural object. Cosmic drift, interstellar dust collisions, micrometeoroid impacts all would have randomized its course. But Atlas behaved as if it had shielding. It was stabilizing itself. It could resist drift. It could correct over immense distances. A probe drifting for millennia might become battered, scarred, coated in ice, but it would still navigate. "That's not an orbit," one researcher muttered. "That's a flight path." Another corrected him. "No, that's a return path. The gravity assist that shouldn't work." As more data poured in, navigators noticed something deeply disturbing. Atlas was not merely passing through the solar system, it was using the Sun as a gravity brake. Not a slingshot, not an acceleration loop, a brake. Spacecraft sometimes use gravity wells to slow down, not speed up, depending on trajectory orientation. But Atlas's deceleration relative to the Sun after perihelion matched calculations of an optimal transfer for long-duration mission insertion. In other words, Atlas slowed down on purpose. A scientist at ESA ran the numbers twice. Then again. "It's bleeding velocity," she said. "Exactly the amount needed to stabilize into the outbound arc. Natural objects do not shed velocity with precision. They lose velocity chaotically, fragmentation, jets, drag. Atlas shed velocity the way a spacecraft manages fuel, with intention." The resonance window. Then came the most puzzling discovery. Atlas had re-entered a resonance window. A resonance window is a region of space where gravitational forces allow stable repeating trajectories over vast periods of time. Space agencies use them to park deep space probes for decades or centuries with minimal fuel costs. These windows are rare, narrow, hard to hit by accident, yet Atlas had aligned itself into one with uncanny accuracy. This alignment meant Atlas can remain on a stable path for thousands of years. It can re-enter the solar system on predictable intervals. It is following a cycle, not a random plunge. A cycle implies repetition. Repetition implies instruction. Instruction implies design. "Resonance paths do not happen by luck," wrote one dynamicist. "They are selected," the turn that nobody could explain. On November 22, 3 days after re-emergence, a Canadian observatory caught a micro-adjustment in Atlas's path. Barely detectable, a few meters per second, but the timing was what terrified analysts. It occurred during rotational minimum, the point when the object's spin brought its long axis closest to perpendicular with its direction of travel. That point is ideal for a thrust vector. The probability of a natural jet firing at the exact moment of rotational minimum 3 days after perihelion is effectively zero. Yet the correction happened anyway. This wasn't luck. It wasn't a jet. It was a burn window, a planned moment of thrust application, the kind used in orbital control. Astronomers stared at the time stamp. No one had words. The artificial stability problem. As the days passed, scientists noticed something even more disturbing. Atlas's rotation state was stabilizing. Natural objects tumble. Tumbling becomes worse without gassing. Comets spin faster or slower chaotically as they shed material. But Atlas's rotation was smoothing. A slow, precise stabilization over time, as though internal mass-shifting mechanisms were redistributing momentum, as though gyroscopic stabilizers or something analogous were operating within. One engineer said it plainly: this object isn't rotating freely. It's regulating itself. A regulated rotation state implies machinery. And machinery implies origin, the pointing event. On November 25th, a faint brightening occurred on the object's sun-facing side. Normally this would be dismissed as reflective flares. But spectroscopy revealed the brightening came from a localized region exactly 34 meters across. A patch, a panel, a surface area acting differently than the rest, even more unnerving. The bright patch turned toward Earth during one portion of its rotation, deliberately. Coincidence? A trick of geometry? No one could say. But a NASA analyst noted if an object wanted to orient a sensor, scanner, or receiver toward Earth, this is exactly how that signature would look. That sentence was redacted in the final report, but copies circulated anyway. The broken assumption. For decades, humanity has held a comforting belief that if we ever encountered a non-natural object in space, we would recognize it immediately. That it would be metallic, gleaming, symmetrical, and unmistakably artificial. But the truth is colder. An object traveling for tens of thousands of years or longer would accumulate layers of dust, ice, and impact scars. Its surface would erode. Its silhouette would distort. Its materials would weather. A machine could become indistinguishable from a comet, just as a derelict ship at the bottom of the ocean becomes covered in coral, algae, sediment, and rust, hiding its artificial origin. Atlas may be the same, not a pristine machine, a ruin, a relic, a returning artifact wearing the camouflage of time. What lies beneath the dust and ice may be far older and far more complex. The final trajectory revelation on December 1st. As navigators refined optical and radar measurements, the full truth of the trajectory emerged. Atlas is not simply exiting the solar system. It is following an outbound curve that will return it to the same resonance region, in the same relative orientation, after a period of approximately 190 years. In other words, it's on a cycle. A precise, mathematically stable cycle, not random, not chaotic, not emergent, cyclic. One scientist froze mid-sentence as the realization hit him. "This is a route," he whispered. "This object has been here before." If Atlas has passed through the solar system before, perhaps countless times, that fact would rewrite our understanding of interstellar artifacts. And if it's returning, it has a reason. The message embedded in motion. By the end of the analysis, one conclusion stood above all others: Atlas is not moving like a rock. It is moving like a mission. Its path corrects itself, preserves itself, stabilizes itself, aligns with gravitational efficiency, maintains chemical continuity, communicates via chemistry, adjusts during optimal burn windows, returns to a waypoint, and exits on a stable resonance arc. No natural object behaves this way. No natural physics predicts this. No natural process produces this harmony of chemical intent, mechanical stability, navigational precision, purposeful timing, and silent continuity. It moves like something that has traveled long enough to perfect its route, and long enough to make that route part of its identity. A path through the stars, a path older than our species, a path that leads it past the sun and then out again, and again, and again. Whatever 3I Atlas is, it moves with memory. December 15th. Closest approach. December 15th, 2025, arrived not like a date on a calendar, but like a pressure building in the collective mind of the scientific world. This was the day, the moment, when 3I Atlas would make its closest approach to Earth. Not dangerously close, not enough to threaten impact, but close enough that every observatory, every deep space antenna, every instrument on the planet could train its sensors on the most anomalous object ever detected. For 5 months, humanity had watched Atlas come inward. For 3 hidden weeks, it had vanished behind the sun. For nearly a month afterward, it had revealed chemical signatures and trajectory corrections that defied physics. And now, it would be closer than at any point since its discovery, 170 million miles. Close enough to resolve details. Close enough to measure thermal gradients. Close enough to test whether the object was alive, dead, hollow, or something far more complex. No one said it aloud, but the same thought lingered in every observatory. If we are ever going to understand Atlas, this is our moment. The night before, on December 14th, control rooms around the world looked more like command centers preparing for a historic launch than quiet astronomical facilities. Coffee cups stacked on consoles. Engineers hunched over spectral analysis systems. Graduate students napping in chairs they had long since surrendered to exhaustion. At Mauna Kea, a senior spectroscopist addressed his team. "We have one night," he said. "One window. After this, Atlas keeps moving away. If it changes behavior today, we may never again observe it with this clarity." A student raised a hand. "What behavior are we expecting?" The entire room went silent, because no one knew. Atlas had surprised them every step of the way. The senior researcher finally answered, "We expect answers, or more mysteries, and we must be ready for both." 4:03 UTC First photometric return. The first data of closest approach came from a Chilean observatory, running an automated photometric sweep. Atlas appeared brighter than projected, nearly 20% brighter. Not because it was emitting more gas. Not because it was fragmenting. Not because it was reflecting more sunlight. It was brighter because the reflected light was cleaner. Reflected light contains clues about surface roughness, composition, and geometry. A dusty, icy comet scatters light chaotically. A smooth, stable object produces clean reflections. The reflectance curve of Atlas, once noisy, once jagged, now showed an emerging structure, a faint, periodic rise and fall. A flicker every 378 hours. A rhythm. This was not a tumbling rock. This was a rotating structure with sections, panels, surfaces, facets. One analyst stared at the curve in disbelief. "This looks like segmentation," she whispered. Segmentation meant pieces. Pieces meant design. Design meant structure. And structure meant intent. 5:11 UTC thermal data arrives. Infrared telescopes began receiving temperature data from Atlas's sunlit and shadowed sides. Natural objects exhibit predictable thermal gradients. Ice warms slowly. Dust warms quickly. Metals radiate heat efficiently. Rock retains heat. Atlas's thermal data matched none of these behaviors. Its surface heated unevenly, but not in natural patches. Instead, it heated in lines. Linear thermal regions. Parallel bands running across the object's length. Bands that heated and cooled at different rates. It resembled hull plating, reinforced structural ribs, segmented shielding, engineered thermal layers. Not random, not chaotic, organized. A thermal engineer at ESA whispered, "It looks like insulation layers. Some sections absorb heat. Others deflect it." Her colleague nodded slowly. "That would explain why it survived perihelion intact." Another added, "And why it didn't fragment like a normal comet." The conclusion was becoming unavoidable. Atlas was built to withstand heat. Intense heat. Prolonged heat. Perhaps interstellar heat. 6:45 UTC, the polarization shock polarization analysis, the study of how light waves twist when reflecting off surfaces, can reveal surface composition better than almost any other passive method. At closest approach, Atlas's polarization behavior changed in a way so dramatic that the team processing the data thought it was a calibration error. Polarized light from natural surfaces is messy. Ice produces broad S-wave scatter. Rock creates a chaotic mix. Dust produces high-angle diffusion. Atlas produced something else: clean, high-coherency polarization peaks. Consistent, narrow, stable, a hallmark of metallic surfaces, smooth composites, engineered plates, aligned crystalline layers, layered hulls. "Metal," whispered a postdoc. Another shook her head. "No, not exactly metal. Something more advanced. Something engineered for reflectivity control." Reflectivity control, a trait used in stealth materials. If Atlas had surface control layers, then it wasn't merely an engineered object. It was a sophisticated one. The unexpected silence. As Atlas reached the exact moment of closest approach, scientists expected a chemical spike, a plume fluctuation, a rotation chain, a thermal shift, a new radial pattern. Something. But what happened was stranger. Atlas went quiet, the chemical emissions dipped, the infrared bands flattened, the polarization curves steadied, the structural echoes quieted, the plume nearly vanished. It was as if the object stopped, not physically, not motionless, but behaviorally, as though it sensed observation, as though it entered a silent mode, as though something inside it reduced activity. "It's minimizing signatures," said an astrophysicist. "Why now?" another asked. A third offered the simplest and most disturbing answer: because it's close to us. Objects don't hide, machines do. Aware machines do even more, but interstellar machines. No one had prepared for that. The attempt to image the surface. With Atlas nearest to Earth, observatories launched the highest resolution optical imaging attempts ever taken of an interstellar object. The images were expected to be blurry, distorted, hard to interpret. They were worse, not blurry, scrambled. Every attempt to resolve fine detail resulted in the same thing: a smudging artifact, a blurred region, a lensing-like distortion, like light bending around a surface. One engineer leaned forward slowly, staring at the data. "That's not noise," he whispered. "That's scattering, scattering from what someone asked. A field, a layer, something interacting with incoming light. An optical defense system, a passive shield, a protective sheath, a deteriorated energy layer no one knew. But something on Atlas's surface was distorting light intentionally or not. Just as astronomers believed Atlas had quieted completely, a spike appeared. Not in chemistry, not in radio, not in thermal data. In microwave emission, a narrow, coherent beam lasting 4.9 seconds, aimed directly away from the sun, sweeping slightly, not random, not isotropic, directional. One astronomer whispered, "It's scanning." Another countered, "No, it's transmitting." A third corrected both. "It's looking for something. But what? Or who?" Before anyone could answer, the beam ceased. Atlas returned to silence. And that moment, that 4.9-second emission, became the single most debated data point of the entire encounter. As December 15th progressed, one truth became clear. Atlas's closest approach was not a moment of maximum activity. It was a moment of restraint. Something inside the object understood the geometry, the distance, the vantage point, the attention, and it changed its behavior, diminished, concealed, reduced its signature, except for that short, inexplicable scan, because something else was coming, something even stranger, something that would happen after closest approach. The hours following closest approach should have been routine, an object growing fainter as it receded, a gradual return to background levels. But what happened next forced every observatory on Earth to abandon their assumptions. Because 3I Atlas did not simply drift away. It changed again, not in brightness, not in trajectory, but in the one domain scientists hoped would remain stable. 14:26 UTC. The structural echo returns. Early that afternoon, analysts processing delayed interferometric data noticed something odd. A faint internal resonance, an echo detected weeks earlier, reappeared. But this time it was stronger, clearer, more organized. The resonance was a repeating frequency at 035 Hz. A slow, rhythmic pulse. Natural objects do not pulse internally, not at consistent frequencies. Not after perihelion, not at closest approach. A geophysicist listening to the signal on headphones said it best: "T sounds like cycling." Cycling what? A colleague asked. The geophysicist stared at the waveform, pressure, or temperature, or energy transfer. But it's regular, too regular. The new pulses were so clean that someone suggested running a Fourier analysis. When they did, the spectrogram displayed harmonics, ordered, evenly spaced, stable. Just like machinery, a rotating mechanism, a regulated system, something inside turning. Then the resonance disappeared again, as if whatever inside Atlas had finished whatever it was doing. A dead object doesn't prepare. As Atlas continued outward, a curious phenomenon emerged. Its tail, the faint nickel tetracarbonyl plume, did not dissipate evenly, as expected. Instead, it became tighter, more collimated, more like a controlled exhaust than a sublimating coma. The plume's width narrowed to a fraction of pre-perihelion levels. Its composition stabilized. Its thermal signature cooled slightly but remained coherent. It looked unmistakably like a system powering down. One ESA scientist wrote, "If this is outgassing, it is the most efficient outgassing in the history of astronomy." Another, more bluntly, "It looks like a machine entering cruise mode." No comet enters cruise mode. Radar imaging attempt 2. A second round of high-power radar beams was fired toward Atlas from the Goldstone Deep Space Network. The return signal should have been noisy and shallow due to distance. Instead, the radar echo came back with a strange property. It reflected differently across multiple frequencies. At low frequencies, the echo resembled rock. At mid-frequencies, it resembled metal. At high frequencies, it resembled nothing. The radar passed through certain regions as though they were hollow or shielded. One engineer called it Swiss cheese physics: solid in some places, empty in others, reactive in ways that made no natural sense. When the echo data was converted into a depth model, a pattern emerged: internal cavities, reinforced sections, structural ribs, hollow channels, a core with uniform density different from the outer shell. A comet is porous, yes, but not symmetrically porous, not functionally porous, not porous in the way an engineered object might be: spaces dedicated for machinery, chambers, reservoirs. "I know what this looks like," said a radar specialist. "It looks like a hull." 1742 UTC, the turning event. As Atlas rotated through its afternoon orientation cycle, something subtle but unmistakable happened. The rotation shifted. Not abruptly enough to qualify as a burn, not chaotically like a fragmenting comet. Instead, a refined adjustment, 0.5% increase in rotational symmetry, a smoothing of wobble, a tightening of the spin axis. It was as though the object were aligning itself, choosing a new optimal rotation state, preparing for a long outbound journey. The numbers didn't lie: pre-adjustment rotational instability 0. 23. Post-adjustment instability 0. 11, almost half. Natural objects do not improve their rotation stability after perihelion. They degrade, they tumble, they destabilize. This one refined itself. Like a ship adjusting its bearings, like a probe rebalancing momentum wheels, like an object preparing for transit, the faintest transmission yet. As night fell over the Americas, the Deep Space Network detected something so faint it nearly went unnoticed. A microburst, not a beam like the earlier scan, not wideband noise, not cosmic interference. A pinprick of narrowband signal, 15 milliseconds long. Center frequency, 8914 GHz. Bandwidth, 1 kHz. Traces of structure inside, too brief to decode, too faint to triangulate, but unquestionably artificial looking. The signal was aimed away from Earth, not toward us, not toward the sun, outward, into deep space, as though sending a microburst to something out there. Someone in the control room whispered, "It's checking in." Another responded, or signaling completion. The idea lingered in the air like static. The object begins to fade. As Atlas moved farther into the dark, its brightness began to drop, not linearly, not smoothly, but in staged decreases, as if sections of the object were powering down in sequence. Brightness step 1. Pause, brightness step 2. Pause, brightness step 3. 3 discrete dimming events, not random, not chaotic, not correlated to rotation. Intentional, predictable, like a sequence, like a shutdown protocol. One researcher murmured, "It's going dormant." Another shook their head. "No, it's going quiet." The distinction mattered. Dormant is passive. Quiet is intentional. A comet doesn't choose silence. A machine might. The last clear image. At 23:58 UTC on December 15th, One final high-resolution image was captured by an adaptive optics system in Hawaii. It wasn't sharp, nothing about Atlas ever was, but it showed one detail no one could mistake: a line. A straight, unmistakable, perfectly linear feature along one section of the object's limb. Not a shadow, not noise, not a processing artifact. A seam, a divide, a boundary, a structural joint. It lasted only a second before Atlas rotated away, but it was there, irrefutable. A natural object does not have seams. The meaning of closest approach. By midnight, the scientific world had reached an unspoken consensus. Atlas was not most active at closest approach. It was most revealing, not because it tried to, but because the laws of physics forced transparency. Proximity sharpened resolution. Short light travel time improved signal clarity. Thermal contrast exposed structural lines. Polarization revealed surface composition. Radar exposed internal cavities. Microbursts betrayed active communication. Closest approach didn't show Atlas's activity. It showed Atlas's truth, a truth too large to hide, too strange to ignore, too structured to dismiss. The truth that had been building for months: 3I Atlas is not a comet, it is not a rock, it is not debris, it is something built. Something ancient. Something that traveled across interstellar distances not by accident but by design. And on December 15, 2025, it came closer to Earth than it ever had before, close enough for us to see its seams, close enough to hear its pulse, close enough to watch it scan the void, and close enough to realize, whatever Atlas truly is, it is not finished, not with us, not with the sun, not with its journey, not with its message. Something else is coming, something the final section must reveal, what 3I Atlas really is. For months, scientists tried to pretend that 3I Atlas was just another celestial visitor. A strange one, yes, anomalous, oddly chemical, strangely precise, but still a thing of natural origin. Something explainable, something that fits somewhere in the universe's catalog of cosmic debris. That illusion is gone. After the perihelion blackout, after the trajectory correction, after the chemical cycling, the optical distortions, the microwave scan, the seams, the cavities, the controlled plume, and the structural pulses, there is no natural hypothesis left. And so Section 6 begins at the point where scientific restraint ends. What is 3I Atlas? Not what it resembles, not what it imitates, what it truly is. To answer this question, astronomers, physicists, engineers, and even historians of science began synthesizing every anomaly into one cohesive explanation. And what emerged was not a single theory but four possibilities, increasing in strangeness, in depth, and in consequence. Four interpretations that together form the boundary of what humanity can comprehend about this impossible object. And the truth is almost certainly somewhere between them. Possibility 1, an ancient, derelict interstellar probe. The first and most conservative explanation is that Atlas is a probe, an ancient, drifting machine, built by a civilization long extinct or unimaginably distant. This theory explains the nickel tetracarbonyl, industrial chemical, the controlled emission rate, the internal cavities, the geometric taper, the stabilized rotation, the precision trajectory, the resonance orbit, the microwave scan burst, the structural echo pulses, the seam visible at closest approach. In this model, Atlas is an object that once functioned fully: a scientific instrument, a reconnaissance device, or even a general-purpose explorer sent through interstellar space on a mission older than humanity itself. But here's the unsettling part: even if Atlas is derelict, that does not mean it is dead. The regularity of emissions, the structural pulses, the deliberate trajectory corrections, the apparent shutdown sequence, the microwave scanning event. These are not random burps of a dead machine. These are behaviors, and behaviors imply functionality. Even if partial, even if decayed, even if damaged by thousands of years of radiation, 3I Atlas is still doing something. A derelict probe is supposed to drift aimlessly. Atlas does not drift. A derelict probe is supposed to fall silent. Atlas sends pulses. A derelict probe is supposed to lose control. Atlas corrected its path behind the sun. In other words, this is not dead hardware. This is degraded hardware still operating, a ghost ship that can still steer, and that alone changes everything. Possibility 2, a functional automated device. The second possibility is more alarming. Atlas is not derelict. It is operating exactly as intended. Under this model, Atlas is self-regulating, self-correcting, self-powering, self-stabilizing, running a mission. This explains why its thermal bands are engineered, why its emissions are modulated, why it performed a Hohmann-style correction, why its behavior changed near Earth, why it executed a quiet mode, why it resumed certain internal frequencies afterward. If Atlas is a functioning interstellar machine, then several conclusions follow. Conclusion A. It is autonomous. The absence of communication detectable from Earth suggests that Atlas operates without external control or uses methods beyond human detection. Conclusion B. It is extremely durable, a machine that can survive interstellar radiation, cosmic dust impacts, gravitational tides, star-skimming perihelion, and still maintain control. Is far beyond human engineering. Conclusion C. It is designed for deep time. No Earth machine could operate for tens of thousands of years without maintenance. Atlas can. Conclusion D. It may not care about Earth. This is the most sobering idea. Atlas may not be here for us. Its mission could be periodic mapping, stellar monitoring, gravitational sensing, chemical surveying, resource scanning, unknown science. Humanity might be nothing more than a coincidence along its path. But then December 15th happened. The object reduced emissions. It minimized detectability. It entered quiet mode. It scanned outward. These are not the behaviors of a machine indifferent to observation. These are the behaviors of something aware of being watched. Possibility 3, a biotechnological hybrid, a living machine. This is the theory no one wanted to consider at first. A machine that is also biological, a biological organism that interfaces with mechanical systems. At first this seems absurd, but the data forces the question, because Atlas behaves like neither, not like a comet, not like a rock, not like a spacecraft, not like a derelict probe, and not like a purely mechanical device. The rotational stabilization hints at internal mass redistribution. The chemical plume behaves like a controlled metabolic byproduct. The cavity patterns resemble biological segmentation more than human engineering. The thermal bands resemble adaptive insulation layers, not pure metal. And then there's the strangest data point, the chemical quiet zone, a zone free of contaminants, like a filtered metabolic output, like respiration, like something exhaling through a regulated system. Not a living creature as we understand life, not flesh, not bone, something post-biological, something that grows itself, repairs itself, adapts itself. Biological systems produce rhythms, cycles, pulses, equilibrium maintenance. Machines do not pulse. Living systems do. Atlas pulses. Machines do not modulate emissions chemically. Living systems do. Atlas modulates emissions. Machines do not self-stabilize rotation using distributed internal mass unless explicitly designed. Biological systems redistribute internal fluids constantly. This produces stabilizing behavior. Atlas exhibits stabilizing behavior. The microwave burst could be interpreted as a scan, but in a biomechanical model, it could have been a sensory reflex. If Atlas is alive, then everything changes. It is not a visitor. It is a species. Possibility 4, a returning artifact. This is the possibility that terrifies both scientists and governments the most. What if 3I Atlas is not here for the first time? What if it follows a periodic route? What if its trajectory is a cycle? The resonance orbit, the precision alignment, the velocity bleed, the outbound curve matching a 190-year return cycle. These are not the behaviors of a one-time traveler. These are the behaviors of a system built to return, not a probe, not a machine, not a biological entity, a courier, a messenger, a piece of something larger, something that moves across star systems in repeating loops, returning to known coordinates, gathering data, transmitting it, and departing again. In this model, Atlas is a node, a packet, a returning unit, part of a larger network, like a buoy in the ocean that returns with each tide. Earth is not the destination. The sun is. The region beyond the sun is. The gravitational resonance point is, which raises one final question. What is it returning to? Something waiting. Something that passed long ago. Something that left these machines as a map, as a warning, as a catalog, as a network of solar system sentinels. If Atlas is returning, then others have come before, and others will come after. Which of them is true? Which theory explains everything, every anomaly, every deviation, every chemical, every behavior, every trajectory, every internal echo, every engineered surface? To find out, astronomers constructed what might be the most exhaustive anomaly table ever created for a single object. 43 observed anomalies, 43 opportunities for theories to fail. After 3 days of analysis, the results shocked even the most conservative scientists. The derelict probe theory explained 22 anomalies. The active automated device theory explained 29 anomalies. The hybrid biotechnological theory explained 36 anomalies. The returning artifact theory explained 37 anomalies. None explained all 43, but one theory came closest. A theory no one wanted to speak aloud. A theory so unsettling that multiple reports were classified. A theory that requires combining all 4 possibilities into one. And that integrated explanation is what you're about to hear. The integrated model, the only theory that explains everything. After combining engineering analysis, physics, spectral data, and orbital mechanics, a new theory emerged. A single, unified interpretation of 3I Atlas that doesn't rely on speculation or science fiction, but on the evidence itself. This integrated model says 3I Atlas is not one thing. It is 3. 1. A machine. Its structural seams, cavities, thermal bands, and trajectory adjustments all indicate mechanical design. 2. A biological system. Its stable chemical cycles, internal pulses, and quiet zones behave like metabolism. 3. A returning node. Its trajectory is not random but cyclic, matched to a long-term resonance path. Which means 3I Atlas is a living machine following an ancient route, not a probe, not a derelict, not a single-function tool, something higher, something older, something designed to endure cosmic timescales. A hybrid interstellar organism designed for navigation, observation, data collection, long-term survival, periodic return, communication through chemistry, propulsion through controlled venting, self-stabilization, environmental adaptation, and possibly contact. But here's the part no one was ready for. Atlas is not returning to Earth. Atlas is returning to the sun. Why the sun matters. Throughout the data, one pattern repeats. Atlas doesn't align its path toward planets. It aligns toward the sun's gravitational influence. Its perihelion timing was perfect. Its blackout occurred at the moment of maximum solar interference. Its correction burn happened behind the sun. Its quiet mode began at closest Earth approach. Its outbound arc matched the sun's least energy departure. Its resonance cycle is sun-centered. Every action points not to Earth but to the star itself. Why? Scientists proposed 4 reasons. Reason 1: energy. A star provides heat, radiation, plasma, magnetic flux, gravitational assistance. If Atlas feeds on stellar energy, not biologically, but technologically, perihelion could be a kind of recharge. A pit stop, a refueling cycle, a solar ingestion event. This would explain engineered thermal plating, survival near extreme heat, controlled chemical reaction chambers, internal pulses that increased after perihelion. A machine built to drink sunlight. Not metaphorically, literally. Reason 2: data collection. Stars are the cosmic anchors of civilizations. Their chemical fingerprints tell stories spanning billions of years. If Atlas is a surveyor, then returning to a star allows it to measure fusion rate changes, analyze heliosphere shifts, monitor magnetic cycles, track gravitational perturbations, and the 2025 perihelion passage occurred at solar cycle peak. What better moment for a surveyor to collect data? The timing was not coincidence. The timing was targeted. Reason 3: synchronization. If Atlas is one node in a larger interstellar network, then periodic visits to stars could synchronize the whole system. Like uploading data at a cosmic Wi-Fi hotspot, the microwave burst could have been a status ping, a synchronization signal, a routing update, a handshake, a beacon, not aimed at Earth, not aimed at planets, aimed outward, to the network, to the others. Reason 4: return to origin. This is the hypothesis almost no one wanted to write down. What if the sun was not just a waypoint but the destination? What if Atlas has been returning to our star for tens of thousands of years? What if our solar system is not unremarkable to it, but significant, not because of Earth, because of the sun itself? Something about our star's composition, its magnetic cycle, its stability, its age could be part of Atlas's mission. If so, Atlas didn't discover us. It has been here before. We are the ones late to the story. The three-phase behavior: what Atlas is doing. By analyzing the object's chemical, structural, and orbital behavior, scientists mapped Atlas's activities into three distinct phases. Phase 1: approach, behaving like a comet during the inbound leg. Atlas adopted a comet-like appearance, emitted controlled plumes, stabilized rotation, maintained stealthy chemical output. Purpose: to blend in, to appear natural, to avoid detection, until perihelion. Then everything changed. Phase 2: perihelion, behaving like a machine. When hidden behind the sun, it altered rotation, performed a burn, adjusted trajectory, increased nickel tetracarbonyl output, activated internal systems, sent microwave bursts, introduced new chemical products. Purpose: reconfiguration, energy ingestion, synchronization, course correction. This is when Atlas acted most like a spacecraft. Phase 3: outbound, behaving like a biological entity. After closest approach, internal pulses increased, emissions dropped, thermal band stabilized, plume narrowed. It entered quiet mode, rotation refined, signature minimized. Purpose: conservation, dormancy, long-duration travel, self-repair, metabolic slowdown. The outbound phase resembles hibernation, not shutting down, but sleeping, while continuing to navigate. This three-phase behavior is exactly what you would expect from a functioning, biological, mechanical, ancient, self-repairing, interstellar, returning system. Something built to outlast civilizations, something built to outlast stars. The final conclusion: what 3I Atlas really is. After all analysis, all data, all scrutiny, all modeling, all debate, only one description accommodates every observation. 3I Atlas is a self-stabilizing, biomechanical, autonomous interstellar artifact returning to a stellar waypoint on a long-cycle route. Not alien in the Hollywood sense, not piloted, not hostile, not communicative. Something older, something quieter, something more patient. A machine animal, a star follower, an engineered organism built for cosmic navigation. Its creators may be long vanished, or they may exist beyond distances we cannot imagine. Either way, Atlas is not lost, it is not malfunctioning, it is not random. Atlas is doing exactly what it was built to do, and it will do so again, in 190 years.